Sin x is equal to 3/5 and x is between 0 and 90 degrees. This means that x is in the A quadrant, so all of the trigonometric ratios, the sine, the cosine and the tangent, will be positive. We want to find the exact value of cos x. There's two ways of going about this. The first one is that we can draw a triangle. Sin x is 3/5 and we know the sine is the opposite divided by the hypotenuse. So if this is the angle x, the opposite is 3, the hypotenuse is 5, and we should know here the 3, 4, 5 triangle, or if not, we could use Pythagoras' theorem to work out the third side as being 4. We can then read off that the cosine of x, which we know is the adjacent over the hypotenuse, is 4/5. An alternative way of doing this is to use the identity sine squared theta plus cos squared theta is the same as 1. We're given the sine is 3/5, so sine squared theta would be 3/5 squared, then we'd have plus cos squared is the same as 1. This is 9/25 plus cos squared is 25/25. So cos squared x is 16/25. And square rooting gives cos x would be plus or minus 4/5. But we know because of this that the cosine is positive, so it must be the positive root. Note that we get the same value. Now to find tan x, one method is just to use the triangle that we've drawn above, so we can see that the tangent is the opposite over the adjacent, and so the tangent of x would be the opposite, which is 3, divided by the adjacent, which is 4. A second method would be to use the identity tan x is sin x divided by cos x. Sin x we know is 3/5, and we're dividing by cos x, which is 4/5. Turn the second fraction upside down and multiply, and we get left with 3/4. It's encouraging to note that we get the same answer both ways.